My name is Lena Wampach and I'm a doctoral student at the Luxembourg Center for Systems Biomedicine. Today I'm very excited to explain you a bit what my project is about, and I hope I can give you some exciting facts on science. In the COSMIC study, which is a project I'm working on, I'm trying to find an answer to the question: how might bacteria influence the later health status of a newborn? You might think, well, that's quite easy because bacteria cause infection and infection causes disease, so what's special about that? However, there is another domain that comes to that has been previously highly under-researched and which is really important in that aspect. So let's have a look at it. Our body is composed of a countless number of cells that then form our organs, and through our organs we are able to breathe, to run, to speak, to laugh. However, there's another level of countless cells that is inhabiting us as well. That's the bacteria. And this is then what we call the human microbiome. So all the microorganisms that live in and on our body. And actually, this is quite a lot. So newest estimations say that there are as many microbial cells as there are human cells. So in the digestive tract alone, those account up to 2 kilograms only of bacteria. You might think that this is kind of gross, but actually the microbiome is very important for our health. So the human microbiome maintains a lot of roles and functions for our body, which is very important. So for example, the human microbiome can produce energy and also vitamins that we cannot produce ourselves, and also they positively stimulate the immune system. So in a normal balanced state, so a normal healthy microbiome in the gut, we have an equal amount of good beneficial bacteria and those that can sometimes turn bad. And in that case, we have a nice communication between our microbiome and our body, and everything works fine. However, under certain circumstances, for example, under exaggerated antibiotics intake, this can lead to an overgrowth of those less beneficial bacteria, which then causes a shift in the microbiome, and this will then cause inflammation. And actually, this imbalanced state has been linked to several disease developments, such as asthma and other allergies, atherosclerosis, cardiovascular disease, even type 2 diabetes and obesity, as well as inflammatory bowel disease and also colorectal cancer. In our study, we are interested in newborns and how they acquire their very first microbiome. And actually, this very early colonization is very important for the baby, because the microbiome contributes to the maturation of its immune system as well as the digestive tract. And it has been shown that early disturbances in a very fragile process of early colonization can increase the probability of the infant of developing chronic childhood and adulthood diseases later on. For example, again, type 2 diabetes or obesity. In the COSMIC study, let's have a look at the 3 big W's. So where, who, and why. So where is the study? It's a Luxembourg-based study, and we are in collaboration with a hospital, a biobank, and then the third, where I work, the research facility. And who does it concern? Well, we are interested in taking up newborn infants that are either born naturally, vaginally, or by C-section, because C-section infants again have a higher statistical risk of developing obesity or type 2 diabetes afterwards. So why are we doing this? Actually is to see if there is a potential link between an early imbalanced microbiome and a later health issue in C-section infants. For this, we designed the study in a way to really collect a lot of samples during 1 year and frame all of the important steps in the life of a baby. So we have the mother, and then we have, of course, birth, and then we have 6 collection time points over the course of 1 year. And at each time point, we are collecting a lot of different data for mother and baby. How are they doing? How is their health? How is the weight of the baby? Is he having breast milk or formula milk. And then, which is the most important, is stool. So because stool samples reflect the best the microbiome of our gastrointestinal system tract. And then from the stool we are trying to find out which bacteria are inside and if their composition is imbalanced or healthy. To give you a little example on how these data look like, we can here see the difference in microbiome between delivery modes. So first of all, let's concentrate on the vaginal birth. So the color at each time represents a different group of bacteria, and the bars then represent the different days where the samples were collected, so from 1 to 1 year. So we see here that for the vaginal birth there's a nice flow of colors, there's a nice proportion at each time, which does not considerably change a lot over time. However, if you see for C-section birth, actually the colors are all over the place. So there's a lot of different bacteria present at each time point, and also, for example, here, bacteria that are not present at vaginal birth. And then we of course want to see and want to know if this has any implications for the health of the baby later on. For vaginal birth, so what is known so far is that, of course, as the child is born vaginally, the first microbiome, the first bacteria to colonize the baby are coming from the mother. So there's direct bacterial transfer from mother to infant through birth. And then this will then result in the development of a healthy microbiome and hopefully also a healthy child afterwards. For a C-section birth, however, as the baby is not born vaginally, there's no contact with the vaginal environment and not the contact with the vaginal bacteria of the mother. So there, in that case, we have a bacterial transfer from the environment, but also from skin, for example. Not that this is necessarily bad, however, it's not how it's supposed to be naturally. In that case, this can lead to a development of an imbalanced microbiome, and in worst case, this could lead to health issues later on. And we want to see if there is any link with the early disturbances in the microbiome. So, as a little summary on what we learned today, I'd like to go over those points again. So, we saw that the gut microbiome, so all of these bacteria that live in and on us, remember those 2 kilograms, they are very important for our health and also for newborns because they are very important for the immune system and for their maturation. A disturbance in the early microbiome, however, can lead to later diseases and health issues. And the COSMIC study then tries to describe these imbalanced microbiome profiles and what also causes them, so that we can see, oh, there's a cause and maybe we can change it next time so that it will not result in imbalanced microbiome. In that case, this study aims towards a better health care for babies. I think everybody will agree that this is a very important point. So this is then the end of my presentation, and I want to thank you for listening to me. And in case you have any questions, just drop a question down below. And thanks to all the people that are involved and that keep pushing COSMIC forward. Have a nice day.